Hello and welcome. I'm Dr. Pauline Fu. In this video, I will introduce data collection. Topics include practice of statistics, observational studies versus designed experiments, simple random sampling, other sampling methods, bias in sampling, and designed experiments. The objectives for practice of statistics will define some terminologies and will explain the process of statistics. We distinguish between qualitative and quantitative variables, distinguish between discrete and continuous variables, determine level of measurement. What is the statistic? Statistic is a science of collecting data, analyzing data, and draw conclusions. The process of statistics usually has 4 steps. The first step to define the objectives. The second step, collect data. Step 3, summarize and analyze the data. Step 4, draw conclusions. The terminologies involved in statistical thinking is population. Population is all the people or objects being studied. For example, all students at Brock University, that is the population. Sample is a part of population. For example, students at mathematics department are sample of students at Brock University. Parameter is the characteristics of a population. For example, the average final mark at Brock University is 63. So 63 is a parameter because it describes the population characteristics. If I say the average mark at mathematics department is 62, that is a statistic because mathematics department, students at mathematics department is my sample, okay? So that is some terminology. Next one, distinguish between qualitative and quantitative data. Qualitative data is allow for classification of individuals based on some attribute or characteristics. For example, my nationality is Canada, so I'm a Canadian. Nationality is qualitative data. How many children do I have? I have 1 child. That one is quantitative data. It provides numerical measures of individuals. My household income is quantitative data. Again, it provides numerical measure of my income. my highest level of education is a PhD. So that is a qualitative data. It is a classification of education level. When you graduate, you get bachelor degree, and that is a qualitative data, the level of education of bachelor degree. Daily intake of whole grains is a quantitative data. It provides numerical measures for the daily intake. So that is a qualitative data and quantitative variables. Okay. If the data is quantitative data, we can further divide quantitative data into discrete and continuous data. Okay. Discrete variable is a quantitative variable that has either a finite number, for example, number of children, or a countable number of possible values. For example, how many hours do you study in a week? So those are discrete variables. Continuous variables. It is a quantitative variable that has an infinite number of possible values. For example, the household income, okay? You have your household income, I have my household income. Between your income and my income, there are many different incomes, okay? Many, and infinite. Okay? That is a continuous data, okay? Has an infinite number of possible values. Daily intake of whole grains, that is a continuous variables. Again, it has an infinite number of possible values. So far, we divide data into qualitative and quantitative. On another hand, we also divide data based on level of measurement. I will talk about the connections between these two categories. Okay? So this is the level of measurement. We have 4 different levels of measurement. I will give the name, then I will explain. Okay. One is the nominal data. Nominal data, it is just the name of an object. Okay. The value of the variable name, label, and categorize. For example, how do you come to the campus? By bus, by car, or on foot? So bus, car, foot, that are the means of transportation. It is a nominal data. Next one is ordinal data. Ordinal data has the property of nominal data. It is the name or label of object or people. And it has the order, specific order. For example, at the end of the term, you will be assigned a letter grade A, B, C, D, and F. That letter grade is ordinal data. Another example would be, which year are you in the university? Are you freshman, sophomore, junior, or senior? Those are ordinal data. And then we have interval data. Okay. If I ask you, when did you graduate from high school? You may say in 2010 or 2015. Calendar year is an interval data. Okay. A value of 0 in interval data does not mean a value of 0 in interval data does not mean the absence of the quantity. Okay. For example, this year is the year 2020. Last year was 2019. The year before last year was 2018. So you continue this pattern until you reach, we have year 1, year 0. That year 0 does not mean the absence of the year. It is just a way to mark that year, year 0, year 1, year 2, until year 2020. Okay. Another example for interval data is the temperature. Okay. When temperature is 0, okay, when temperature is 0, that does not mean the absence of temperature. It is just 0. Okay, we know the mixture of ice and water, that temperature is 0. Okay, above 0, you have, for example, today we have maybe 28 degrees. Okay, in the winter, maybe you have minus 15 degrees. So that is the interval data. And the last one, it is a ratio data. Okay. If I ask you, how much does it cost for your textbook? So your textbook, the price of your textbook is the ratio data. Okay. Again, the ratio data is the highest level of all measurements. Okay. You can give any other examples. For example, number of snacks and soft drink in school. That is the ratio data. Okay. So now, so far we divide data based on level of measurement, and we are saying based on level of measurement, we have nominal data, ordinal data, interval data, and ratio data. Okay, this is on one hand. On another hand, we also discussed quantitative data and qualitative data. So this number 1 and number 2 belong to quantitative data. Quantitative data. Okay. And number 3, interval and ratio is quantitative data. And inside this quantitative data can further divide into discrete data and continuous data. Discrete and continuous. Okay. So that is the connection between different types of data and the level of measurements. In summary, nominal data and ordinal data belong to qualitative data. Interval data and ratio data belong to quantitative data. Quantitative data can be further divided into discrete and continuous data. So that is the data. Next, we'll introduce the observational studies versus designed experiments. Okay. We are going to distinguish between an observational study and an experiment, explain various types of observational studies. observational studies measure the value of response variable. So what is the response variable? Response variable is Y. Y is response variable. Without attempting to influence the value of either the response or explanatory variable. Explanatory variable is X, is this direction. Is X. Is the explanatory variable. So observational study, you don't control explanatory variables. This is observational study. Researchers just observe in our natural settings. They don't control variables. However, if researcher assigns individual in a study group, the researcher want to change the value of explanatory variables. Okay. Want to change X, and then recording the value of Y. This is a designed experiment. Okay. So let's take an example. Observational study or designed experiment. Do flu shots benefit seniors? Researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 years and older. The researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get a flu vaccination shot, and Group 2 were seniors who chose not to get a flu vaccination shot. After observing the seniors for 10 years, it was determined that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza, and 48% less likely to die from pneumonia or influenza. So this one, do you say it is observational study? Or for this one here, design experiments. This is observational study, okay? It is observational study. Because the researchers didn't control the patients, the seniors, okay, the objects of being studied. They just observe two different groups of people to see which group have likelihood of hospitalized. So this one here, another example. Determine whether each of the following studies depict an observational study or an experiment. If the researchers conducted an observational study, determine the type of observational study. We will use the following examples to explain there are different types of observational studies. So let's look at this example. Researchers wanted to assess the long-term psychological effects on children evacuated during World War II. they obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental status were evaluated using questionnaires. It was determined that the psychological well-being of the individuals was adversely affected by evacuation. So is this observational study or designed experiment? So this is observational study because the researchers just observe the consequences of being evacuated or not being evacuated, okay? It is a case control, okay? Because researcher, it is just going backward to analyze the cases. It is a retrospective studies. So next one. Xylitol has proven effective in preventing dental caries when included in food or gum. A total of 75 Peruvian children were given milk with and without Xylitol and were asked to evaluate the taste of each. So this is the designed experiment because the researcher divide the children in two groups on purpose. One group has the milk, the other group without milk, okay? Next example. A total of 974 homeless women in Los Angeles area were surveyed to determine their level of satisfaction with the health care provided by the shelter clinic versus the health care provided by government clinic. The women reported greater quality satisfaction with the shelter and outreach clinics compared to the government clinics. So this is observational study, okay? Because researchers just naturally observe two groups of people. One group of people is at shelter clinic. The other group of people at government clinics. The researcher didn't do anything for those two groups of people. It is also cross-sectional study because those two groups of people are observed at the same time, same year, same month. Okay. This example you can look at yourself, and at the bottom you have the answer. This is observational study and it is a cohort. So observational study has three different categories. One is cohort, the other is a case study, and still the other is a cross-sectional. So that concludes the observational data and designed observational study and designed experiment. Next topic is about simple random sample, okay? The objective is to obtain a simple random sample. I'm going to use Excel to demonstrate how do you get a simple random sample. Suppose we have 100 students and we want to choose 5 students from these 100 students randomly. That means each and every student have equal chance of being selected. How do we select these 5 students so that each and every student have equal chance of being selected? Step 1, we give those 100 students a number. So start with number 1 and number 2. So each student has a number until we have 100 students. Oops. Oops. So now I created 100 students, okay? Each student have a number. And then I will use random number generator, okay, to select 5 random numbers between 1 and 100. So in Excel, I will type in equal rand between from 1 to 100. And then I use this method to create 5 random numbers. Okay, so the number I get is these 5 numbers. That means students with number 73, 81, 88, 14, and 9 are being selected. Okay. So that is the simple random sample Excel demonstration. Now let's look at another example. Suppose a study group consists of 5 students: Bob, Patricia, Mike, Jane, and Maria. 2 of the students must go to the board to demonstrate a homework problem. List all possible samples of size 2. So we need to choose all possible samples of size 2. Pick 2 students. Okay, so we can pick Bob, Patricia. Oops. Bob, Patricia. So I want to use pencil. We can pick Bob, Patricia. And then Bob, Mike, Bob and Jane, Bob and Maria. Okay, so this is 4 samples. I repeat: Bob, Patricia, Bob, Mike, Bob, Jane, Bob, Maria. Okay, then you can have other samples. For example, Patricia, Mike, Patricia, Jane, and Patricia, Maria. Okay, and you have Mike, Jane, Mike, Maria. Lastly, you have Jane, Maria. Okay, so those are the possible samples of size 2. I repeat, in case you didn't catch it. So all possible samples of size 2: Bob, Patricia, Bob, Mike, Bob, Jane, Bob, Maria, Patricia, Mike, Patricia, Jane, Patricia, Maria, Mike, Jane, Mike, Maria, Jane, Maria. So that is the simple random sample. Okay. Besides simple random sample, we have other methods to obtain a sample. One is a stratified sample. Those are stratified sample, systematic sample, and cluster sample. Okay. Let's do the stratified sample first. Okay. Stratified sample. It is one obtained by separating the population into homogeneous groups called strata, and then obtain a simple random sample from each strata. For example, Canada has 13 provinces, territories, okay? And in each of those 13 provinces and territories, you can randomly select some students. And that way you get a stratified sample. Systematic sample. I worked for Statistics Canada 20 years ago. And one task is, back then we did a census. We need to give household a survey paper questionnaire. Some household were required to fill out the long census form. Other households were required to fill out short census form. And how do we decide which household will get long form, which will get a short form? We use systematic sample. We give each, every fifth, by the way, we give a household number, 1, 2, 3, 4, etc. And then we give a long form to those household has the number divisible by 5. For example, the 5th household, the 10th household, the 15th household, etc. Those households will get a long census form. So that is a systematic sample. Okay. Next one, cluster sample. Cluster sample is obtained by selecting all individuals within a randomly selected collection of groups or individuals. Okay. So for example, if you divide a population, for example, Brock University have many different departments, and each department, you randomly selected some students. That way you get a cluster sample, okay? Actually, you select all students in that department. So the difference between the first one, stratified and clustered, is that in stratified, you select some people, okay? And in cluster, you select all individuals within the randomly selected collections. So that is a sampling method. So in summary, we have a random simple sample, and we can get samples through stratified sample, systematic sample, and cluster sample. Okay. Next one is the bias in sampling. The objective is to explain the source of bias in sampling. There are 3 sources of bias, 3 sources. One is the sampling bias. Okay. sampling bias means the technique used to obtain the individuals to be in the sample tends to favor one part of the population over another. Non-response bias. Non-response bias refer to not responding from the people you sent the survey to. Okay, they don't respond. Last one is the response bias. Response bias exists when the answers on a survey do not reflect the true feeling of the respondent. So those are three sorts of bias. The last topic in this video is the design of experiments. We are going to introduce some examples. Through these examples, I will explain the concept. Okay. So let's take a look at this example. The English department of a community college is considering adopting an online version of the freshman English course to compare the new online course to the traditional course. An English department faculty member randomly splits a section of her course. Half of the students receive the traditional course, and the other half is given an online version. At the end of the semester, both groups will be given a test to determine which performed better. Question 1. Who are the experimental units? So one terminology, what are the experimental units? In this example, the students, all the students in that class is experimental units. Generally speaking, an experimental unit is a person, object, or some other well-defined item upon which the treatment is applied. And there's another terminology, treatment. What is the treatment? Okay. To explain treatment, we have to explain the experiment. An experiment is a controlled study conducted to determine the effect of varying one or more explanatory variables or factors has on response variable. So in this definition, we have explanatory variable, that is our X, response variable, that is our Y. Okay, so an experiment is a controlled study to determine the effects of X on Y. Any combination of the values of the factors is called treatment, means different X values is the treatment. So let's go back to this example, question 2, the population. Obviously, all students in that class is the population. Okay. And question 3, what are the treatments? In this example, traditional delivery method and online delivery method are the treatment. Okay. Question D, what is the response variable? Response variable is Y. Okay, Y variable, vertical axis. We want to compare two groups of students. One is taking online class instruction, the other is taking traditional. We want to see if the average mark for those two groups of students are different or the same. So final mark, final exam mark is the response variable. Why can't this experiment be conducted with blinding? Okay. What is blinding? Blinding refers to non-disclose of the treatment an experiment unit is receiving. Why this one cannot be blinding? Because both students and the teacher know what method of delivery they are receiving. For design of experiments, we will introduce two different methods. One is a completely randomized design. We are going to look at an example. Example, designing an experiment. The octane of fuel is a measure of its resistance to detonation with a higher number indicating higher resistance. Engineering wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. Assist the engineer in designing an experiment. So how do we design an experiment? This example. Step one, we need to identify the objective. Okay, what we are going to accomplish in this experiment. We want to see the miles per gallon. Okay, so we want to identify the response variable. Okay, y, the vertical y variable. So y. Step two, we need to identify factors that affect miles per gallon. Okay, and we know those: the engine size, the temperature, driving style, and your driving experience, driving conditions, and also the car, the characteristics of the car. Okay, those will affect miles per gallon. And once we identify these factors, we then select 12 cars made of the same model, same year. Okay. If you select a car using different model, different year, you cannot do this experiment because you don't know, maybe it is the model or maybe it is the year will affect miles per gallon. So we just choose the same model, same year, but a different car. We select 12. And then we list the variables and their level. Okay. We have octane level manipulated at 3 levels. Okay. Treatment, we have 3 treatments. Treatment A, 87 octane. Treatment B, 89 octane. Treatment 3, 92 octane. Engine size, we assume they all have the same engine size. Again, temperature, we assume they have the same temperature. Driving style conditions, we assume they're all under the same conditions. Other characteristics of the car, all 12 cars will be the same model year. However, there is probability from car to car. To account for this, we randomly assign the cars to the octane levels. Okay. So what we do, try to adjust. Okay. So this is a completely randomized design. We select 12 cars, same model, same year. We assign 4 cars to 87 octane, 4 cars to 89 octane, 4 cars to 92 octanes. And then we record miles per gallon and then make comparison. Okay. After you make comparison for these 12 cars, because these 12 cars are sample, you can draw conclusion about the population, all the cars made in that model that year, okay, about their miles per gallon. So that is the completely randomized design. The other method is random block design. So again, let's look at an example. So we are going to take a same example as we did before. The English department is considering adopting an online teaching method for the freshman English course. After some deliberation, the English department thinks that there may be a difference in the performance of the men and women in the traditional and online courses. To accommodate any potential differences, they randomly assigned half of the 60 men to each of the 2 courses, and they do the same for the 70 women. So we can use randomized block to design this experiment. Okay, the block is the gender. We have a male block, we have a female block. Okay, and if you look at this diagram, this is how the randomized block design works. Total, we have 130 students, 60 male students, 70 female students. We divide this class into 2 blocks. Block 1, 60 male students. Block 2, 70 female students. And for block 1, 60 male students, we assign 30 male students into online class and 30 male students into traditional face-to-face class. For the block 2, 70 female students, we assign 35 female students to online class and 35 female students to traditional face-to-face class. And then we compare the final exam or final mark, okay, for the 2 groups. Okay. That is the design of experiment. Okay. All right. In summary, this video introduced data collection. We talked about terminologies about statistics, population, sample, parameter, statistics. We also talked about the steps in conducting of statistical analysis. And then we introduced simple random sample and other sampling methods. We also introduced observational study versus design of experiments. For observational studies, you have 3 different types of observational studies. Okay, one is cross-sectional studies that collect information about individuals at a specific point in time or over a very short period of time. That is the cross-sectional studies. We also have case control studies. These studies are virtual retrospective, meaning that they require individuals to look back in time or require the researcher to look at existing records. In case control studies, individuals who have certain characteristics are matched, those who do not. The last observational study is cohort studies. A cohort study identifies a group of individuals to participate in the study. The cohort is then observed over a long period of time. Over this time period, characteristics about the individuals are recorded. Because the data is collected over time, cohort studies are prospective. So finally, we talked about the design of experiments, two methods. One is the completely random design, and the other is a random block design. Okay. All right. That's all for this video. Try to bring the robot. All right. So I'm trying to finish. Right. Oh.